Okay, section 5.3 is called the binomial distribution. So if we look at our notes, a binomial experiment is a probability experiment that satisfies the following 4 requirements. There's a fixed number of trials, there's 2 outcomes, the outcomes are independent, and the probability of success is the same for each. The outcomes of a binomial experiment and the corresponding probabilities of these outcomes are called binomial distributions. Okay, my PowerPoint had some issues. So distribution should go on this blank. And these are called successes or failures. All right. Let's see. There's some notation you need to know. The symbol for the probability of success is P of S. The probability of failure is P of F. The numerical probability of success is lowercase p. The numerical for failure is little q. There's the formula, or part of the formula. The probability of S is little p. The probability of failure is 1 minus the probability of success, which is q. The number of trials is n, and the number of successes is x. Okay, here's the probability formula for binomial probability. We are not going to use it. We're going to use our calculator. Okay? An example, if a family has 3 children, find the probability of having exactly 3 boys. I'm going to show you that in a few minutes. Computing probability using this formula can be tedious. They're talking about the formula on the previous slide. It is a nightmare. So we have a table that I'm going to post for you that you'll be able to use, or you can use your calculator. Alright, we need to find the mean, variance, and standard deviation for a binomial distribution. Here's the formula for mean. That's mu equals n times p. N is the number of items, p is the probability of success. The variance is sigma squared, which is n times p times q. Q is the probability of failure. And the standard deviation is the square root of that. Okay, let's see. All right, let's do a few problems. Okay, let's start out. We're on page 283. Let's look at number 1. It says, which of the following are binomial experiments or can be reduced? That means you can make a fixed number of trials, 2 outcomes, their outcomes are independent, and the probability of success is the same. A says, surveying 100 people to determine if they like sudsy soap. You could get them to say yes or no, so this could be a binomial experiment. B, tossing a coin 100 times. You either get heads or tails, so this could be. C, drawing a card with replacement. That means you put it back every time from a deck and getting a heart. That probability is always going to be the same. D, asking 1,000 people which brand of cigarettes they smoke. There's a bunch of different cigarettes they could say, so this is not. And E, testing 4 different brands of aspirin to see which is most effective. That you can't break that down into a yes or no question or a this or that question, so it's no. All right, let's talk about number 3. Okay, now number 3, part A, we're going to use the chart to compute the probability of S successes. So I got N is 2, P is 0.30, and X is 1. Okay, let me see if I can pull up my chart. Okay, so you need to find the chart that looks like this. And I know this is hard to see, but you can see on your handout. We need to find an n value of 2, which is here. All right, we need to find a probability of 0.30, which is up here across the top. And we need to find an x value of 1, which is right here. So you have to line all of those up. So n is 2, the probability is 0.30, and x is 1, which is right there. I had my finger on the wrong one. So the answer is 0.420. Now, let's talk about how to do the same kind of thing with the calculator. I'm going to do the same problem. So if I get my calculator, and the yellow calculator is pretty much the same, you're going to go there using the stat key. I'm going to hit data. Second data. I'm going across the top over there to DISTR. I'm going down to binomial PDF and hit enter. Okay, I want a single. This is where I put in my info. Like it told me n was 2. It told me the probability of success was 0.30. And it told me my x value was 1. So when I calculate, I'll still get the 0.42. Okay? The chart is best to use if you have to get several pieces of data. The calculator is easiest to use if you just need to get a couple of things. Okay? Let's do one more problem. So let's flip and let's find, let's see, number 5. Wait, no, I'm sorry. Let's do 7. 7 says, a television commercial claims that 1 out of 5 of today's marriages, that's your probability of success, begin as an online relationship. Assuming this is true, calculate the following for 8 randomly selected, that's your n, today's marriages. All right, A says find the probability of at least 1. Okay, that means 1 or greater. So that's going up to 8 because 8 is my n. Okay, so these are my x's. If I take my p-value, make it a decimal, this is going to be 0.2. So I would go to my chart, I'd line up an n of 8, a probability of 0.2, I'd find all of those values in the chart, okay? I think I have those written down, but I'm not sure. Let's see, 1, 2, 3, 4, 5. Okay, the answer is 0.832. I'm going to leave that for you to sit there and see if you can figure it out. You can let me know if I need to help you with that. Okay, part B says 2 or 3. Okay, so I'm going to find the 2 or the 3, add them together. I should get 0.441. And C, what's the probability that exactly 1? So I just find 1, which is 0.336. Okay? The last kind of problem is 17. 17 says, find the mean, variance, and standard deviation. So if we do letter A, it says n is 100. It says letter P is 0.75. All right, we need to find Q, so that's the complement, which is 0.25. Okay? The mean is N times P. So N times P, that's 75. The variance is N times P times Q. So 100 times 0.75 times 0.25, that's 18.75. And the standard deviation is the square root of that, which is 4.33. Okay, let me know if you have questions.